Okay. Okay, let's proceed. And the last will be constructivism, which has have been dominant for a long time, that describes learning. And somehow most science and mathematics teaching, instructional models, and even pedagogies were anchored on the principles of constructivism, where we see learning as an active process, and we do acknowledge that our students have these pre-existing ideas or schema, that they can really associate to what the things to the things, I mean to say, that are they are encountering or they are experiencing in nature. Eventually, these experiences that they have, these prior knowledge that they have, will be used as we can capitalize, or we can capitalize it as a springboard in order to cup or to come up with a baseline of understanding of our students on a particular lesson that we are presenting to them. So we have to recognize that our students come to our class, that they have this existing ideas. There are different literatures that would suggest that and describe this perspective. Others use the term P-prims. Others use these terms as their schema, or and then eventually they come up with ways of categorizing this as either a form of misconception or a form of transitioning to a more acceptable scientific form of knowledge. Okay, so we have to recognize this kind of perspective, that our students is not really a sponge that will be entering to our students, that they will be absorbing everything, because they have a prior knowledge based on their experiences. Okay. In this context also, we have to recognize, in this learning theory, I mean to say, we have to recognize that the learner's knowledge is described as a conceptual structure. Therefore, the students have the ability to structure and to reshape their understanding and their learning. So in constructivism, let me emphasize that there are two main processes as described by Piaget. Apologies for the misspelling for that. Okay, it's more of the assimilation and accommodation. It's a form of trying to alter the prior knowledge based on the new knowledge that they are acquiring. That's accommodation. Assimilation is a process of trying to fit in their existing knowledge to what they have, or their experiences to what they are trying to experience right now. Therefore, in that sense, we tend to describe that learning is a process or a cycle of assimilation, cognitive disequilibrium, meaning to say the students experience some mental challenges on whether to accept or not the new learning that they are acquiring or experiencing. Then the process of accommodation, where we try to provide more evidences to our students that this is the more acceptable scientific and mathematical concepts. Then eventually they try to incorporate it to come up with a cognitive equilibrium. Then the next session will be a form of assimilation again. So that's how we try to present learning based on the context of constructivism. And eventually, because of constructivism, we were able to understand the significance of scaffolding. Okay, this is a manner on how we, as science and mathematics teachers, provide different learning tasks of different levels that will bridge the current status of the understanding of our students, whether it is a form of misconceptions or a transition to a more acceptable conception. We try to link it to what we desired for them to understand or to learn. So that scaffolding approach, which is highly emphasized in constructivism. So constructivism, as mentioned earlier, has been dominant in our understanding on how students really learn, particularly in science and math. Thus, we tend to come up with different practical implications that we still recognize and practice. Okay, first is the carefully guided discovery. When it was mentioned when constructivism, I mean to say, was popularized, we were able to provide discovery approach to our students. But as time goes on and based on literature, we were able to come up with a good documentation that the best way to introduce discovery for our students is on the context of carefully guided discovery that would lead to a more effective learning in science and in mathematics, because we wanted our students to be actively engaged in the development of the idea out of tapping their curiosity and providing learning tasks that will enable them to discover and to relearn. Okay, the idea, what I mentioned, is to relearn because we recognize that our students have this kind of prior knowledge. Okay, then we also recognize that in based on constructivism, the role of teachers is more of the facilitation of learning that would provide students support on their personal activities, particularly in meaning making. Okay, so what we wanted is that we provide learning activities to our students that will make sense to them. But the question is, how do learning activities really make sense to them? Then we will discuss it later. Okay, and in this context, we wanted to emphasize that it is also necessary as science and mathematics teachers to assess these pre-existing ideas, or what we in other literature they suggest or they define it as alternative frameworks or alternative understandings of our students in order to maximize modification of their conceptual understanding. That's why in 1990s, the most recent trend in terms of science education and mathematics education research is more of how do students really experience conceptual understanding using different innovative instructions. And then we wanted to verify what are those pre-existing ideas of students eventually manage to come up with a more appropriate and relevant learning task in order to elevate this pre-existing knowledge into a higher or acceptable form of knowledge. Okay, and because of this, we were able to identify different misconceptions of students in science and mathematics, which we have to be more familiar, or we have to be familiarized with, because we wanted to, as I mentioned earlier, we wanted to capitalize on this schema of our students in order to come up with appropriate understanding at the same time of identifying what are the prerequisite competencies that we have to firm up to our students in order that when they are encountering this new topic, they were able to come up with a more acceptable understanding of the lesson. Okay, so in this case, we wanted to re-emphasize the significance of constructivism as a way of promoting conceptual understanding and for the students to come up with meaningful learning experiences. So why do I have to come up with this review or recall? Because we wanted to first, we wanted to highlight those best instructional practices that you are already including in your science and mathematics teaching. They have already established certain level of success. But at the same time, it's also necessary that we have to reinvent and we have to understand that there are different perspectives on how we can see learning, because this form of orientation or understanding how our students learn, and I mean to say our orientation on learning and on teaching directly influences the knowledge of teacher in terms of how we will be appreciating the curriculum, how we will be understanding the way the students are learning, how we will be the knowledge of teachers when we are designing instructional strategies, learning materials, and the use of technology, and how that we will be assessing the learning of our students, which captured on the effective teaching model known as the PCK, or the pedagogical content knowledge. And then with the advent of technology, we have the TPCK, including the the great role of technology. That's why we have now the technological pedagogical content knowledge. So these two, or the transition of PCK to PCK will and its tenets provided us a more understanding on how understanding and guidance on how we science and mathematics teachers or the STEM teachers will able to come up with better means and ways on how we will be improving and describing how effective our science and mathematics teaching.